Hello, 7th grade math students. Today we're going to videotape a couple of lessons for you. We're going to first look at lesson 3.4, which again comes from the 7th grade Math and Focus textbook. We are going to practice expanding expressions and then simplifying algebraic expressions after that expansion when needed. So if you were to look at your worksheet, lesson 3.4, I know that I've assigned the odds to you. Odds numbers 1 through 31, and also that back page with the geometry problems. So I just pulled a few similar problems to kind of help you out if you're feeling stuck. If you take a look at this first one, we're given a fraction times the quantity of 2k minus 15. If you take a look in parentheses, if I was following PEMDAS, I would first want to simplify the parentheses. But if you notice inside here, I have unlike terms. I have a variable term and I have a constant. Those won't go very well together, will they? But I do notice something else. Before I move on, there is a subtraction sitting here. And if you remember, we've learned to add the opposite. Or change a minus to a plus, change the sign of next. And we're ready to roll. So in PEMDAS, parentheses don't help me out a lot right now. They are showing a grouping of sorts, but I can't do anything inside besides change that minus to a plus, change the sign of next, or add the opposite. Next up, there are no exponents, but there is technically some multiplication. If you take a look, secretly, what's always happening here between any number and a parenthesis which is right next to it? Oh, this open parentheses is showing me a multiplication happening here. I really am going to take this 3/5 and distribute it. Another word for this, expansion, is distribution. I'm going to distribute or share this 3/5 with both of the terms inside. I do want to remind you, we did talk about this in class, that it's dangerous to distribute over anything besides addition or subtraction. So this one's good. I currently have a subtraction, if I keep it the way it was, or an addition problem inside those parentheses. I can distribute, I can expand. Technically speaking, what this really means is I want to take 3/5 times the first term, times 2k. Next, I want to take 3/5 times that negative 15. So again, I'm distributing. I'm showing that that 3/5 visits both terms inside parentheses. And is it possible to have more than two terms in parentheses? You betcha. Well, I have this pretty well set up, but I noticed something. I went from an addition here in my parentheses to no symbol at all. I really want to bring that addition down to get ready to roll. All right, we're getting close here. So if we look at the next step, I want to simplify. I want to turn this 3/5 times 2k into a single term. And I want to turn this 3/5 times negative 15 into a single term with multiplication also. Well, I sure wish this 2k looked more like a fraction. Or could it? Oh, that's right. Any whole number could be written over 1, just like 2k could be written over 1. Well, I don't see any cross simplifying on this one. So I would say, what is 3 times 2k? Or 3 groups of 2k. Well, 2k, 2 more k's, 2 more k's. That's going to get me 6k. And notice my denominator is really 5 times 1, or 5 when it's simplified. Let's look at the second term here. I really want to take 3/5 of negative 15. Well, that really means this negative 15 might be better to see as a fraction. And when I say that word of, I'm talking about finding 3/5 of this number. So some people can kind of visualize that. And other people want to kind of go this route and maybe show some cross simplifying. Oh, this 5 and this negative 15, they do share a common factor. What could I divide them both by? Oh, that's right. 5 goes into both negative 15 and 5 nicely. Well, 5 goes into 5 one time. I kind of emphasize that one. I keep it outside my cross simplification so I can see it's my new denominator. And 5 goes into negative 15, not just 3 times, but negative 3 times. Because remember, a positive times a negative will get me a negative. This works. All right, let's simplify this a little bit more. So this 3 and this 1, they won't cross simplify. I'm ready to multiply across. My original numerator of 3 times my new numerator of negative 3 gets me a negative 9. See, this is kind of in the way here. Might have to erase that guy in a minute. Next, I take my new denominator of 1 times the previous denominator of 1, and I'll still get 1. I am going to go for an erase step here. I'm so sorry that's in the way. Should have planned a little extra space, but I think we got it now. Well, Next up, I need to kind of pay attention. I noticed that there was something happening between these two terms. Go back and take a look. Oh, that's right. It's still addition. Well, your next step is to really combine these as much as we can. So if you take a look, I have a variable term. It has this k. King k is here, or the variable k. And I have a constant. No variables on this term. Can these go together anymore? The answer is no. I do want to do a little rewrite step. This answer wouldn't be bad. In fact, I'd kind of like it. But I'd like it a whole lot better if you told me this is 6k over 5 plus, oh, let's simplify our notation here. Negative 9 over 1 really is the same as a whole number, or I should probably say the integer, negative 9. Hey, this is a nice answer. You know, in class I'd tell you, hey, that gets you a smiley face. That's nice. But do you notice something more? A couple of things. Some students might say, hey, this is an improper fraction. They might want to rewrite that. They might say 6/5 is really the same as 1 whole and 1/5 more. If you decide to go this route, I won't count it wrong by any means, but you want to make sure that that variable term is still sitting here with this k. So that's a possibility. I'm not really pressing for it because we like these improper fractions when we get to our equations and graphing on a number, or graphing on a coordinate plane, I should say. If you take a look at this next piece, I can't change a lot about this, but look at this combination here. This add a negative. Oh, you've learned in class it's the same as subtracting. I can change that back to subtraction to save on some notation, and I could say this is a possible answer. I don't mind that too much either. Let's talk about a final answer though. It might be best just to keep this 6/5 k as an improper fraction, because at one point we will turn this into slope, we will be graphing, and notice this k, this variable, it can sit next to the whole fraction, kind of like saying this whole quantity is a variable term, or it could sit in the numerator. Do not put it in the denominator. We are not dividing by k. And I could change this to subtract by 9. Oh, this is probably the best and most algebraic answer in this situation. Cha-ching. I see one more possibility. I could have put a k in the numerator and eliminated that 1 over here in this possible answer, but I really like this one best. I'd say this is the most algebraic we can get. All right, next up. We have a second problem coming at us, but this one involves decimals. It still has this expansion idea, or this distribution, because I see parentheses with something inside and a number immediately preceding it. A number right outside is telling me, hey, let's multiply. All right, think Pem does. Check those parentheses first. Can we combine the x's and the constants? The answer should be no. Don't do it. These are unlike terms. They can't go together. But here I grabbed another one with subtraction. So what might you want to do? Change a minus to a plus. Change the sign of next. Or add the opposite. Students who are not showing this step tend to forget that that's a negative quantity. And oftentimes they'll make an error right here. So I do think this is a good move in our work. And of course, when we're done, if we can turn it back into subtraction, we may. Well, because I can't do anything more inside parentheses, I next look for our exponents, which we don't have right now, and multiplication or division from left to right. Oh, I do. Do remember that there's something secretly hiding here. If you put on your algebra goggles, I'm sure you can see the multiplication symbol happening here. It's really telling me, let's take 1 5/10 times 0 4/10 x. And 1 5/10 times, oh yeah, negative 1 3/10. That's a constant back here. We're going to multiply again. All right, let's give this a try. Well, hopefully you know that 4 times 15, kind of ignoring those decimals for a quick minute, would get you, let's see, 40 plus 20 more, 60. Looks like I get 60 from that. And now my pens don't want to cooperate. This could be a problem in the middle of your video. But let's try that. We're going to turn that into 60. But notice these decimals. They're over one place for the first number and one place for the next. That's a total of 2 jumps. I need this decimal to move 2 places to the left. They really are taking this and dividing it by 10. Dividing by 10 again really means divide what you get by 100. That's what I've shown here. And remember, those 7th grade teachers, they like to see this whole number up front, so please show that. Now be careful, we spent so much time thinking decimals for a quick minute that we almost forgot that this is a variable term. Make sure your variable is still there. This is still an x, or a variable term. Next up, I don't want to forget that this negative 1 3/10 can be multiplied by this 1 5/10. I can actually multiply those right now. I might want to stack those off to the side, so I'm thinking for myself, I might show that in another way for you real quick. I might also remind myself that anytime time I have a positive times a negative, I'm going to get a negative. I'm going to plot that in there right now so I don't forget. Well, let's give this a try. 3 times 5 is actually 15, and notice I'm ignoring the decimal. That's fine for now. I'll regroup with the 1 in this next place value. 3 times 1 is 3, plus 1 more makes 4. And I really want to move over. I'm done with this 3, so we will often say, hey, put Bob here, or save yourself a place. We need a placeholder of some sort so that we slide over one spot. What's 1 times 5? Hopefully you say 5, and 1 times 1 is still 1. Notice I don't care about the decimal yet. What's 5 plus 0? Hopefully you say 5. And 4 plus 5? Well, that definitely gets me 9. And 1 and nothing? Well, gets me a 1. Hold up. There's no way this makes sense. I notice that 1.5 or 1.5 is pretty close to 2. And 1.3 or 1 3/10 is really close to 1. 2 times 1? Well, hey, this answer should be close to 2, and right now it's close to 195. A little bit frightening, so we build the decimal bank. If you remember, we've done this in class a few times, where we show how many places over this decimal is. Well, in the first number, I have to jump once to the left. In the next number, I jump once to the left again. That makes a total of how many jumps? What should we save in the bank? 2 decimal places. I'm really going to divide this 195 by 100. Divide by 10 once, twice, divide by 100. This looks pretty good. It almost landed in the right spot, but not good enough for me to keep it there, so I think I have to do a little rewrite again. Not planning my space very well tonight, am I? Sorry, crew. Well, I wouldn't ever encourage you to erase your work, but for this situation, I think that's where we're going right now. So if you remember, I have a -1 and 95 hundredths, and a different color, no one knows why, but we'll roll with it. Next up, what was happening between these two terms? It was addition, so it's still addition. Well, this looks pretty good. In fact, I got rid of the parentheses. That's one major goal in expansion or in distribution. Get rid of the parentheses. Simplify it. Well, I notice I have a variable term and a constant term. This could be a final answer. These can't go together anymore. Yep, this one will get you that smiley face. I'd be really proud if you could get that far. And those decimals are in the right homes, of course. But there's something that we could do even better. If you notice, there's a neat combination happening right here again. Yeah, I kind of chose this on purpose. When you see this add an opposite or plus a negative, we can simplify that. We can turn that into one symbol of subtraction. And the rest of it will really stay the same. So I have 0 and, you know what? I don't even have to write this extra 0 on here, do I? That's just a placeholder in the hundreds place. So I could really simplify a little more and say, this is 0 6/10 x. And instead of plus a negative, I'm going to show this as subtraction. And I'm going to take away the 1 and 95 hundredths. Anything else I can simplify here? Any other notation we can eliminate? No, this is a final answer. This will get you your gold star, or maybe a blue one tonight. Nice work. Here we go. The next thing we're going to look at is a third example. And I think this one gets a little bit tricky because we're missing a coefficient inside these parentheses. We're going to handle the rest of it pretty much the same, but again, there's a missing coefficient. Could be challenging. And I also notice there's a negative being distributed, or we're using this negative in expansion to simplify. All right, check out your parentheses. What can you do inside? Yeah, a whole lot of nothing, besides add the opposite. Well, I'm kind of bothered because in a minute, I know I want to use some expansion. I want to distribute, but this h over here is now a negative h. It doesn't really have a number with it. Where's its coefficient? Well, if I just had h, that's really the same as 1h, isn't it? So if I just have negative h, that must be the same as negative 1h. Oh, let's show the implied coefficient. This is really negative 1h. So we do show extra notation in our work to show where our numbers and our algorithm and process is coming from, but then we kind of do take them out in the final step just to neaten things up. Here we go. I think we're ready to distribute. So this means I want negative 7 times the 4k. And in a minute, I'm going to take negative 7 times that negative 1h. All right, well, I know 7 times 4 is 28, but that's no ordinary 7, that's a negative. So negative 7 times 4 is a negative 28. And do be careful, it was a variable term, it's still a variable term. We have not undone the king. Okay, we keep king variable in place. Next we have negative 7 times a negative 1. Well, I know 7 times 1 is just 7. What about a negative times a negative? Oh, they get along. I'm going to get a positive 7 from that. And I have to notice this has a variable on it, an extra variable. That's okay. I'll call this positive 7h. Be careful what was happening between these two terms. Right now I can't tell, so I go back up to the problem and go, oh, that's right. There was addition. I can only distribute or expand with addition or subtraction in those parentheses or in that quantity or group. Well, if we take a look at this, hey, this is a pretty nice answer. K's can't go with H's, they don't get along. Kangaroos and hippos, not a good combination. I call this answer okay, hey, good for you, not bad. But do you remember a rule that we try to follow? Is there something else that we might want to do for our final answer? I hope you say yes. If you think of the alphabet, let's see here, A, B, C, D, E, F, G, H. H comes before K in the alphabet. That's really indicating I might want to turn this around a little bit. I might want my variable of H to come first. So we grab that 7H, notice it's positive, so I write a positive 7H, and I grab this negative 28K. Do you notice it's negative? I grab that whole thing and I just put it at the back here. And I go back and say, hey, there's still addition happening here. Now I'm following that general rule of ABC order with my variables. This looks pretty nice. Good, you got yourself another smiley. Oh, that means I might not be there yet. If you look, there's one more move. So I did pay attention to alphabetical order, but there's something else that I noticed. There's a combination right here that we've been tuning into tonight. In fact, it's add the opposite. And there's a way to neaten that up. Well, at least to make it simpler, one less line, two less lines, I don't know. We're going to change that to subtraction. Bring everything else down the way it was. Now I have 7H, take away. And notice that negative is that add the opposite, or adding a negative becomes a subtraction. I grab that whole group, it's now subtraction. So I just bring down the 28K. This will get you the golden star, or maybe orange tonight. Next, we're moving on to a little more complexity. When you look at these problems, there's a little more involved. In fact, I see some extra terms. I still see that distribution or expansion because there are some parentheses involved, but I also notice there are some extra terms, more terms to deal with. So I'm going to take this first one, and well, I see a couple of things happening. Lots of terms, that's for sure. I do see these parentheses in here. Notice I'm not on a pen. I might want to fix that. And I think we're ready to roll. Well, PEMDAS says check out your parentheses. Too bad there are A's and constants that don't go together. So I will change the minus to a plus, change the sign of next, and that's really all I can do inside the parentheses, this grouping symbol. Well, next, PEMDAS would tell you to look for exponents. There are none tonight. So next it might tell you to look for multiplication or division from left to right, and in fact, I do have some. If you remember, the 6 that precedes, comes right before those parentheses or that group, tells me to distribute, or expand if you will. Multiply times both of the terms, or all of the terms, depending on what you have, inside. Well, let's look here. I know that 6 times 1/12 is really 6/12. And remember, that's a variable term of A. I don't make my A's like this, so I'm pretty flexible. If you need to change it to our typical lowercase a, I'll take it. And don't forget, the 6 times a negative 3, well, positive times a negative will get us a negative 18. What's happening between these two terms? I hope you'd say addition. Hey, this doesn't look too bad. In fact, you have gotten rid of our parentheses. They're gone. We've simplified what was there. But this is a complex problem because there's a little bit more at the back. In fact, I need to bring down this take away 1/2 A. All right, this is something we haven't necessarily looked at, but I think we are ready for. So if you look here a little bit, I notice a couple of things. First of all, I notice I have 2 variable terms and they seem to match. They both have an A as their identity. Well, I also have a constant. He can't go with very much in this situation. So I want to put together my like terms. You might notice something else also. This 6/12 A, it's kind of jumping out at me. I hope you notice something about it. Could we simplify? Could we turn it into something a little bit different? Little smaller numbers perhaps to work with? What goes into that 6 and that 12 nicely? You could say 2, but we're at the auction now. 2 going once, going twice. Oh, 3. 3 definitely would work. Going once, going twice. Nope, not yet. How about 6? 6 is the greatest common factor, so that might be a good move right now, especially because I notice in a minute my denominators will need to match so I can combine them. 6 goes into 6 one time. 6 goes into 12 twice. Remember, this was a variable term. Get that variable on there. There we go. He's part of the A team. And I'll bring everything else down the way it was. I'm really trying this pizza method that I've, oops, almost dropped a negative, close one, negative 18. This pizza method that I really want you to utilize in class because it makes us a little more honest and accurate with our math steps. Well, if you take a peek, I'm almost there. I now have A's to still go with A's. But before I combine them, today we had a big discussion. It's easy to forget what belongs to this last term. Look at that, subtract 1/2 A. That's the same as saying, let's add a negative 1/2 A. Oh, that will make a big difference. So if I were to use a coding strategy, my A's are going to go with my A's. Well, a positive 1/2 A, take away a negative 1/2 A. Sorry, shouldn't have used that double negative. Let's try that again. A positive 1/2 A, take away 1/2 A, or a positive 1/2 A plus a negative 1/2 A. They're really going to cancel out, aren't they? Looks like I'm going to end up with 0 A's. And I still have that constant sitting there, plus a negative 18. Oh wow, if you can get this far, you earned yourself that smiley. You make me happy. You got the right idea about simplifying after expansion. But there's a lot of notation here I don't think I need. What can we do to neaten it up? Well, if you have 0 A's, I could take away the 0, but that wouldn't mean the same thing, would it? A by itself represents 1A. It doesn't represent 0 A's, so be careful. We don't want to do that. But 0 A's, well, I don't really want to show that. That means I have nothing, no A's. So I could instead maybe change it to a 0 or just leave it off. This really will go away, won't it? The last thing we're left with is plus a negative 18. It's kind of like 0 plus a negative 18. Maybe we'll put the 0 back in there just for food for thought. Well, if I had 0 and I add negative 18, if I simplify this one more time, I'm just going to have negative 18, aren't I? This is the simplest form of this answer. This will earn you your gold star, or purple. All right, we have another one to go here, and I notice it has more than 2 terms. It also has a distribution that you might not see often, but this one's very important. It can go wrong quickly if you don't tune in now. Okay, well, parentheses first. PEMDAS rules. Inside parentheses, I take a peek. You have x's and you have constants, and they cannot go together. Next, you have an addition, and there's nothing to do with an addition, meaning I don't need to change it to add the opposite, because there's no subtraction here. So don't fall in that trap. We leave the additions alone. Well, next I would look for exponents. There are none. Next, I would look for multiplication or division from left to right. And the good news is, there is some. It's sitting right here. You say, what? I haven't seen this before. And it's true, you may not have, but we will see a lot of it in equations. Take a peek. This negative out front means distribute the negative to everything inside this quantity. It really means I could show an implied number right here. Doesn't this really mean negative 1 times the quantity of 1 4/10 x plus 5 plus 1 7/10 x? Oh, it definitely does. So this looks a lot better. I can see now that I'm taking this negative 1 times everything inside. Oh, we can do that. If I take a negative 1 times a positive 1.4x, it changes that positive to a negative. And notice it's still a variable term. If I have this negative 1 and he distributes or expands and multiplies times 5, well, negative times a positive still gets me a negative 5. Notice what's happening between these two terms? Still addition. And we're not done yet because there's something at the back that needs to be added on, 1 7/10 x. Wow, you'd love to say, great, I'm done. Parentheses, gone, I did it. Well, that you did do. The expansion you seem to have down. But what should you do next? We want to make this as simple as we can. I noticed something. I have x terms and more x terms. Can't those go together? Oh, yeah, they can. Notice one is a positive and one is a negative. This is a different sign subtract rule. Sometimes we wrote that on our paper when we were early into learning these rules. Well, I can picture in my mind 1 7/10 is the farther number. So if I take away 1 4/10 from it, I'll be left with 0 3/10. Would it be positive or negative? Remember, the farther number determines that answer. And 1 7/10 is farther from 0 than negative 1 4/10 x. And remember, this is still an X-man, like Wolverine. Next up, I have another term that I haven't dealt with. It's an unlike term. I'll give it a different code. I'll use 2 lines this time to say, hey, constant sitting right here. Do we have anything to go with him? The answer is not this time. So we'll bring down plus that -5. Oh, this is looking great. In fact, you just earned yourself a purple smiley. Not too shabby, but not a final answer. Not if you want to win millionaire, or at least feel like one. So take a look. What might we want to do? I can't get rid of any coefficients. That would definitely change the value of x. I do see something else. I notice that there's this combination here. This plus a negative. If you remember, we neaten that up. We go back to subtraction land. We write it as one simple symbol. And I bring everything else down the way it was. Do be careful. I just use this combination to make subtraction. So all that I need to bring down next is the 5. Please check. Are we in ABC order? Oh, you betcha. Is there anything else I can simplify? Not in this case. You just earned yourself your gold star, or blue, as it may be. We are now fast forwarding to some geometry and really an application problem when we need to both expand or distribute and simplify. So the directions for the very back page of lesson 3.4 tells us to write an expression for the missing dimension of each shaded figure and a multiplication expression for its area. Then expand and simplify the multiplication expression. Whoa, sounds like multiple steps to me. Let's grab those real quickly. So the first thing I heard they said was we need to write an expression for the missing dimension. Oh, write an expression for the missing dimension. Part A, you are here. Next it says, and multiplication expression for its area. Part B, you are here. Then don't forget to expand and simplify that expression. Oh, part C, you are here. So I do think it's very important that you do some decoding. Some people might want to use 2 lines for the second part, 3 lines for the third, but I definitely want to identify. I have 3 things to do. Well, the first one is find me this missing piece. Find me this question mark or an unknown. And we will not use a second variable today. We're really working in 1 variable for this unit. 2 variables are really going to hit you a little bit harder when you hit 8th grade math. So let's start here. I noticed something. I know the whole length of this giant triangle. Not the shaded one, but this giant triangle. The shaded piece plus this unshaded portion. Actually, it's right down here. It says this whole thing is 16 centimeters, miles, units. I don't know. We'll make it generic today. We're going to use units. So I'm going to start with that 16, and I notice that they're taking a piece of it away. They're taking away the unshaded part. Well, look right here. That unshaded part is worth what? 2x. I want to take away 2x. And whatever's left would really represent this missing piece, this question mark, this unknown. And I don't need to use a second variable. Again, we're working with expressions in 1 variable today. Hey, this doesn't look too bad. Part A, I'd say we're darn close. In fact, I could take this and say I'm measuring a linear length. I can use the word units because I don't know if it's miles, feet, inches, that sort of thing. And I'll also tell you, this might be relatively new. When you get an answer with multiple terms, it might be important to put it in parentheses and show those units go with all of it. It belongs to the entire quantity. It doesn't just belong to the 2x. Okay, if you can get this far, I say, yeah, you earned yourself your blue smiley. But unfortunately, there might be something you want to look at a little bit further. Before we move on to part B, I noticed something. Well, there is a subtraction here. That's usually okay. But I noticed that the x's come after the constants. Oh boy, we need to turn this thing around. And to turn it around, I would say be very careful. The subtraction might be better seen as adding the opposite. Change a minus to a plus, change the sign of next. Oh, when I rewrite this, it's not 2x going to the front. It's a negative 2x. The variable term gets to come first, but he is negative. He's a grumpy king. There he is, grumpy as he may be. And the 16, instead of going first, it becomes my second term. Notice this is an addition. I turned it to an addition problem so that I didn't forget that negative on my variable term. Oh, this is not a bad answer. I do want to call it units. And I do want to remember those units don't just belong to the 16, they belong to the whole quantity. Part A, final answer. You earned yourself your red star. All right, part B, there's more to be done. It says, let's find the area of the shaded region. Area, Well, I remember something. I need to use an area formula, don't I? So I'm going to kind of move over here where we have a little space. Part B, I know area of a triangle is the same as base times height divided by 2. Or if in the elementary you've learned it as 1/2 base times height, there's nothing wrong with that. That will absolutely work. And in fact, I know my students like to say length times width, but we're kind of moving into that middle school idea, that formula that's a little more regimented for middle school and high school. They oftentimes will refer to it base times height. It means exactly the same thing that you've learned. All right, let's take a look. Well, this shaded region, how long is its base? Oh, didn't I just find that? This unknown piece was negative 2x plus 16. So I'm going to use that in my formula. I'm going to write, I'm looking for, you know what, not sure I want that equal sign. The reason why I say that is we're working on expressions. So maybe I'll just take the base times height. I'll take the base, negative 2x plus 16, and I have to multiply it times the height. Base times height showing right here. So I'll take this quantity times the height of my triangle. Well, how tall is it? Follow this altitude up at a right angle. And, oh, it's labeled across. If it's 8 over here, the altitude must be 8 here within my triangle. All right, we'll take this times 8. I can show that with this parenthesis. And when I'm done, that would be the area of maybe a rectangle, maybe a square, if I was lucky. But I don't want that. I want a portion of that. So how do I go from a square or a rectangle to a triangle? Hi-ya! We really want to find half of it. That's why the formula says divide by 2. Okay, I will. Let's see if we can simplify this a little bit more. So the next thing I'm going to look at is the numerator. It's kind of like reading a newspaper, which maybe you don't do anymore. Or reading online. You start at the top of the column and read down. All right, we need to deal with the numerator first. Nothing to do in parentheses. It's just a grouping symbol. But there's this 8. Happens to be behind the parentheses with nothing in between. That's showing multiplication, of course. So we're going to do a distribution. We're going to multiply times both of these terms. Well, 8 times a negative 2x is really a negative 16x, isn't it? And 8 groups of 16, that's like 80 plus 48 more. So sounds like I'll get 128 from that. 80 and 48. Yep, I feel good about that. And notice there was addition in parentheses in that grouping symbol. There's still addition between those two terms. Yay, this looks great, but don't forget, that's the area of a square or rectangle. We're going to karate chop it, hi-ya, in half, so I can find the area of this shaded triangle. All right, so my next move here might be to divide this entire quantity on the top by this denominator. I hope that they split nicely, and if not, we might end up with a fraction in our answer, maybe a decimal, depending on which route you go. So let me think. Does 2 go nicely into negative 16x? The answer is yes, that's an even number. Negative 8x will work. Next, does 2 go into a positive 128? The answer is yes, it goes in there 64 times. There was addition in the numerator. There's still addition in my result. Hey, this looks really awesome. In fact, you just found me the area of the triangle. Area of the triangle equals this. And I just need to give it some label. So I'm measuring some distance. No, I said that wrong. I use some distance in my formula. I use some distance of a base times a height. So it's like saying meters times meters, or miles times miles, or units times units gets me units squared. Area is always squared. This would be awesome, except I'm scared you're going to think the units only go with the 64. So how do we show that? With some safe parentheses. Guard your answer. This is a final answer for area of the triangle. My question really is, I want to make sure that I did this correctly. Oh, they only asked me for a multiplication expression. A multiplication expression for part B. So part B was actually this piece sitting right here. I probably should do a rewrite because I kind of lost it along the way. Part B should really be how I started the expression before I simplified. Some people might want to see the 8 out front. That's fine. And all over 2. This is awesome. Part B, here you are. That's uncomfortable circling that or saying ta-da, but that's because they didn't want us to simplify. Part C talks about expanding and simplifying. We found the answer, and actually, I probably don't have to rewrite that now that I look. I think we're close. Slide down here a little bit. Part C, we had already done it. It's the area. It's the answer to the area. 3 parts to this problem with geometry. Pretty challenging because, again, we're dealing with geometry that some of us haven't seen in a while. We have area of a triangle formula happening, and you have to learn today that numerators happen before denominators. All right, it's kind of like PEMDAS. Numerators come first. All right, the last one we're going to look at is number 51 from your worksheet. And it says, I want to write an expression for the area of this figure. Expand and simplify. Ooh, a couple things. Write an expression. Part A, you are here. Oh, expand and simplify. It's kind of combined, I would say. Part B, right there. All right, we've worked on these in class a wee bit lately. Take a look. I have a rectangle. Area of a rectangle is really base times height. And I also have a triangle here. Well, we just talked about that one. Base times height divided by 2. Okay, so how do I get there? Let's take this first rectangle. Its base is this whole quantity, 2x take away 3y. It's this expression. And I'm going to multiply that times its height. Well, it's actually 10 tall. So we'll multiply that times 10. 10 could go at the back, 10 could go at the front, and I think most of us like to see the expansion or distribution with the number before parentheses. Next, I'm going to add on the second area. I'm going to add on the area for this triangle. So if I can find its base and its height, I can divide that by 2. Well, its base is sitting right here, isn't it? It's labeled for us. How awesome. It says it's 6y. But I have to take that times its height. So how tall is this thing? Oh, this height's not really labeled. But if you look across, it should be congruent to its opposite edge. Oh, 10. Looks like it's 10 units of some sort. That would be awesome if it was a square or a rectangle. But it is not. So we have to take this, just the triangle portion of our area, and take that formula, make sure you divide by 2. We're following the rules for area of a triangle. There's a formula that goes with it. Maybe you call it length times width divided by 2, or 1/2 base times height. It means the same thing. All right, we're ready to do some simplifying. Well, before I do that, I guess I should say part A, you are here. It just asked me for an expression for the area. I've done that. All right, let's expand and simplify. Well, they say I should expand first. Let's see if we agree. PEMDAS says, look at parentheses. There they are, and there's nothing to do inside besides change the minus to a plus, change the sign of next, or add the opposite. Let's go ahead and distribute. This 10 is going to distribute or multiply times everything inside that quantity or that grouping symbol. 10 groups of 2x is actually 20x. And 10 groups of negative 3y is actually negative 30y. What's happening between those two terms? Oh, I changed it to addition, of course. And this piece is done. But look at the back of the problem. I took care of my multiplication, but there's more multiplication coming at us in another term. So I can also do this along the way. Numerators first. Numerators before denominators. It's kind of like ladies before frogs. A student told me that a few years ago. Here we go. 6y times 10. Well, that means 10 groups of 6y. I think I would get 60y. And remember, I have to divide that by 2 because we're talking about a triangle. Well, what was happening between these terms? Addition. There it is. I bring that addition down and we're ready to roll. Oh, we're almost there. But what do you notice we should probably do? I noticed some like terms. We'll have to deal with that in a second. And I also noticed this improper fraction. Can we fix that up a little bit? Oh, 60y divides by 2. It divides nicely. So I'm thinking I'll just do a rewrite step here up to that point, and let's see what we get. 60y divided by 2. Well, 60 divided by 2 would actually be 30. And because this is a wise guy, or it has y as its variable or as its identity, it's a 30y. All right, I'm almost there. I have 3 terms. What should we check for? Are they like? Well, yes, indeed they are. In fact, I have wise guys to go with wise guys. They get to combine. Let's put them together. If I have a negative 30 and a positive 30, what would happen? They would cancel each other out. Just like if I have a negative 30y and a positive 30y, they're going to cancel each other out. if I go to combine these, I'm going to end up with 0 y's. And, of course, 20x is still there, and I'm still adding. Oops, that's supposed to be addition. Use your imagination. Oh, not bad. If you can get this far, and you can tell me that we're talking about area, so it must be units squared, and you remember to put on parentheses, I would say, you're almost there. This looks awesome. Okay, this is great. This is a good place to be today. Why is it not a final answer? Because we can clean it up. We can get rid of the 0y, can't we? We could just call this 20x, and we will make sure to say it's units squared for area. And we'd still probably put that 20x in parentheses so that you know this whole thing is going to be considered units squared. It's actually the area that we just found. The area equals. So this will get you your golden or bluish star. I hope that you've learned a lot from our expanding expressions. I hope you know how to look out for things like these subtractions, which we change to, or these adding the opposite situation, which we can change back to subtraction in some situations, but sometimes we don't if we have to consider reordering. I hope that you've tuned into labeling. It's a word problem, so bare minimum, give me back something like a label or units. I hope that you're looking for these combinations of add the opposite and this rewrite to get to subtraction again. I hope that you know that when a term wipes itself out, or if the variable terms kind of end up being 0 of something, 0a's in this case, it means I can rewrite it. I can take that right away. Just clean things up a little bit. It's the final answer. I also hope that you're thinking about ABC order. I think we might have had that on this first slide. I'm not sure I see that at this moment. And we always start in these parentheses. If there's nothing to combine, we could maybe change the minus to a plus, change the sign of next, and we look for distribution or expansion when we can. That multiplication times everything in the parentheses. All right, that ends our video lesson of expanding and simplifying algebraic expressions. I hope that you found it helpful. Let me know if you have more questions. I'll always work with you.